Hey guys, we're going to talk about conditional probability for a second. So this new chapter 4 is all about probability rules, and we get into this more difficult thing called conditional probability. Before we get into that, I just want to go over the multiplication rule. So typically when we see the probability of A and B, if the two events are independent, so if one does not affect the other, we can just multiply the two together. This becomes probability of A multiplied by the probability of B. Okay, so a lot of your homework has that. They'll tell you the events are independent. So to calculate a joint probability, we can just multiply the two together. But if these two events, A and B, are conditional, so one affects the probability of the other, we can't just multiply the two together. We have to follow this formula here. Probability of A and B equals the probability of A times the probability of B given that A has occurred. Okay, so let's break this down. How do we calculate this new thing that we see? This vertical line means that we're dealing with a conditional probability. Anything after the vertical line to the right of it means it's already occurred. So this event that has already occurred has some effect on B, so it changes the probability. Therefore, these events are not independent. So this new piece that we see, this probability of B given A, is a formula to calculate the conditional probability. We take the probability of the joint over the probability of whatever has already occurred. Okay. Go ahead and write this formula down because I'm going to use it in the next example that I walk through. Pause the video and read through this example about the New York restaurant. Okay, so before we begin even jumping into A, let's just organize the information that we're given in the problem, okay? Okay, so 45% of customers buy mixed drinks. D is the event that a customer buys drinks, so I'm going to say the probability of D equals 45%. %65% of their customers order appetizers. Therefore, the probability of ordering an appetizer equals 0.65. Okay, last number that we're given, 35% of customers buy both a drink and an appetizer. Probability of buying a drink and an appetizer. Okay, so now we've got everything organized. Let's go ahead and check out A. Suppose a customer bought a drink. What's the probability the customer will order an appetizer? Before we begin any calculations, we always want to think about the probability statement. Obviously, I'm not requiring probability statements. I can't grade them since this is an online class, but creating the probability statements will help you so much with the calculations. So suppose a customer bought a drink. That has already happened. The customer has purchased the drink, so that's given information. That has already occurred. We want to calculate now the probability the customer will order an appetizer. So we're finding the probability the customer orders an appetizer given that they've already bought a drink. So just kind of translating this into that formula, this is equal to the joint probability of both of those, A and D, divided by the given probability over the probability of D. Okay? So this is simple now. Since I have already organized all the info and I have the probability statement, this becomes a very simple calculation. Probability of A and D, same thing as D and A, it doesn't matter the order, that's going to be the 0.35 over the probability of D is my 0.45. Do this calculation out, and we get here we go, 0.7778. Okay. Again, let's start with the probability statement. If a customer ordered an appetizer, what's the probability the customer will buy a drink? Okay, so slightly different from the last one. It's just going to be switched around. Now we're calculating the probability that the customer will buy a drink given that they've already ordered an appetizer, given A. Okay. The previous one was probability of A given D. This is probability of D given A. So the order here makes a huge difference, which we'll see. Again, we're going to use that conditional probability formula, where it's the joint probability, D and A, over the given probability. Okay, simply fill in the pieces. Probability of D and A is the 0.35. Probability of A is 0.65. Calculate this out. We get 0.5385.